Tim Kenyon will be the next speaker. He's a geologist with a lot of experience over the years with oil pipelines and CO2 pipelines, so I will turn it over to him. Give him a round of applause, please.
So we don't get confused. Good evening. My name is Tim Kenyon. I'm a long-term resident of Lake County, been here 38 years. Anybody here live on the lake? Well, I'm the tugboat guy. That's how you know me on the lake. I'm a scientist. I want to tell you a little bit about myself so that you'll understand why I'm here and kind of how I can say what I'm going to say. A bachelor's degree in geology from School of Mines and Technology in Rapid City. I have an engineering degree from School of Mines and Technology in Rapid City. I'm a registered professional geologist in the state of Minnesota. I'm not in South Dakota because no such registration exists. If it did, I would be. Been registered in several other states and recently retired from those states. I spent 5 years in the oil fields in North Dakota, Montana, and Wyoming doing CO2 frac jobs. I learned a lot about CO2, a lot. Saw a lot about CO2. I've been an environmental consultant since 1986, and one of the principal activities of my companies and my personal activity has been the remediation of pipeline spills. I've seen a lot of pipeline spills in my time. Some big ones, some not so big ones, some really bad ones. As part of that, I began to do HAZWOPER training. That's the hazard response. For first responders, I trained fire departments, local emergency planning committees, the Department of Environment and Natural Resources and PIR, the DOT, a lot of different folks. And that was kind of that was a training on how much chemical can you have, what it does to you, what's dangerous, what's not dangerous, and how you treat it. I was on the Minnehaha County Local Emergency Planning Committee. There's one in every county in the state, and they respond to the State Emergency Response Commission, the CERC. I was on that for several years, and served as a term as a chairman on that LEPC back in the 90s. So I have a real good idea and feeling for what emergency response is, what emergency response planning is, how it should be done, how sometimes there's a hole in that plan, and what you really need to look for. A couple disclaimers. I have done a lot of environmental consulting. At this time and for the last year really or so, I'm not under contract to anyone. I'm not working for anybody. I'm not being paid to provide advice, counsel, or opinions to anybody. I'm my own guy. For the purpose of this presentation tonight, I'm neither in favor of nor opposed to CO2 pipelines. As a scientist, I have to look at facts, I have to look at data, and I can't let my personal bias be a part of that. If I let my personal bias in, my credibility goes out the window. And so, for the purpose of this here, I'm neither in favor of nor opposed to CO2 pipelines. I'm here to educate folks. When this was all in the legislature during the session, I had a chance to talk to a number of legislators and other folks in regulatory positions, and it came to me that none of them knew what they're talking about. They didn't realize the hazards associated with one of these pipelines. And I think as policymakers, they have to be able to weigh the benefit against the risk. All they were talking about is the benefit. The risk picture was really kind of blank. You tell me if I'm wrong. The risk picture was kind of blank. So I wrote a letter to every legislator. I didn't really hear a lot back. But what I did hear back was, gee, I didn't know any of this stuff. So what I'm here tonight is to give you guys some of that information, some of the real information. What I'm not going to talk about tonight. I'm not going to talk about landowner rights. That's not science, that's politics. I'm not going to talk about the legislative parts of the legislation. I will talk a little bit about some of the technical details. I'm not going to talk about the appropriateness of eminent domain. That's a political issue, not a scientific issue. So first of all, I want to talk about pipeline. I spent a lot of time Oh man, a lot of time. Pipelines leak. They just do. They leak because they weren't buried deep enough. They leak because the signage that's around the pipeline telling you it's there goes away after decades. They leak because they corrode. They leak because it goes under a stream and there's a big flood in the stream. The stream bed scours down, exposes the pipeline, it leaks. They leak because of traffic accidents. An unfortunate young teenage couple in Michigan were going down a road doing things in the car that they shouldn't have done, ran off a T intersection into a pig launcher on a natural gas pipeline, ran through it, broke it open, huge ball of fire, killed them dead. Traffic accidents. They leak because there's installation defects. Nothing that we build is perfect. They leak because, okay, you're not going to like to hear this. They leak because farmers hit them with their plows. There was a guy 5 miles north of Sioux Falls that was driving his tractor, spring plowing, and he got stuck kind of up on top of the hill. And he could figure, what the heck? How come I'm stuck? And he got off his tractor and he smelled petroleum, but he was driving a diesel tractor, right? Smelled petroleum, he got down and he was stuck in mud. The mud wasn't water mud, it was petroleum mud. And he had hit a pipeline because over the years, this pipeline was installed in 1947, went from Sioux Falls to Marshall, Minnesota. Over the years, the soil had eroded on the top of the hill and the pipeline was no longer buried deep enough to be under his plow. Happens. Construction workers hit pipelines all the time. Utility locators mislocate the utility, causing people to hit it when they're not supposed to. Guys, just a simple thing as digging a post hole. Petroleum's different than CO2. Petroleum is a relatively incompressible fluid. The fluid petroleums we're talking about, gas oil, diesel, crude oil. So when you have a leak in the pipeline, even though it may be under 700, 800, 900 psi, it leaks for just a little while. It leaks until the pressure in that pipeline drops, and because of the incompressible nature of that fluid, not a lot comes out, unless gravity drains out the hole, and it takes a while to do that. Even a natural gas pipeline, natural gas is lighter than air. So when there's a natural gas pipeline leak, somebody hits it, it disperses really pretty quickly because it goes up. It doesn't follow the ground surface. It goes up. Those are some of the differences, some of the key attributes of petroleum pipelines. And I'm going to tell you about CO2, and you'll see how that's a little different. CO2 has a molecular weight of 44. Air is 29. What that tells you is that when CO2 is present in significant concentration, it settles out. It does not disperse up into the atmosphere. It travels along the ground. Some numbers now in parts per million. If you're in an atmosphere of CO2 that's 10%, that's 100,000 parts per million, you will become almost immediately unconscious and cease breathing. 10%. The federal government says the IDLH, that's the concentration that's immediately dangerous to life and health. And it's not really immediate. What it means is if you're in this concentration and it's 40,000 parts per million, 4%, you can self-rescue within a 30-minute without any long-term effects. OSHA says the short-term exposure limit in an occupational setting is 3%, 30,000 parts per million. And that's at 15 minutes. If you're in that concentration for more than 15 minutes, OSHA's going to write a citation to your employer. Hyperventilation, if you're in an atmosphere of 2% CO2, your body's going to say, what happened to my oxygen? And you're going to begin to try to hyperventilate. You're not actually going to, but you're going to try, and that's the feeling that you're going to have. The permissible exposure limit. That's a NIOSH term, National Institute of Safety and Health. And OSHA is called the time-weighted average. It's 5,000 parts per million. That's 0.5%. And that's a concentration that, by law, you can be exposed to as an employee, and you won't have any health effects. That's a quote-unquote safe concentration, 0.5%. So how much CO2 is in our atmosphere? Well, it kind of depends on where you're at. If you're on top of a volcano, it's a lot more. 300 to 400 parts per million, which is 0.03 to 0.04%. There's just not a lot of CO2 in the atmosphere. It's like 74% nitrogen, 20% oxygen, and the rest is carbon dioxide and a whole bunch of other stuff. So when we pump CO2, we pump it as a liquid, and it's called a supercritical liquid. That's when it's a fluid above 1,070 psi and cooler than 87.7 degrees Fahrenheit. Now, what's a supercritical liquid? It's a liquid that has a lot of kind of funny properties. It's both a fluid and a gas at the same time. It has the viscosity of a fluid. You can kind of, under the right conditions, you can pour it. But it has the friction properties of a gas. So it's very good for pumping in pipelines because it's thick, and it's, at that point it becomes relatively incompressible. So you can pump it, you can push it through a pipeline, and it has very low friction. So you don't have to energize it very often. If you go into a CO2 atmosphere, according to OSHA, you have to have an SCBA. You have to have an air tank on your back with a full face mask so you have your own atmosphere with you. Every fire department has those, and that's fortunate. Not sure they have enough. Dispersion. Gaseous CO2 is heavier than air. So when it's released from a pipeline, it comes out as a liquid. It immediately flashes to a gas because all of a sudden you're below that supercritical pressure. It's atmospheric pressure. It flashes to a gas and flows downhill just like water. I've seen this happen. We were doing a frac job in Gillette, Wyoming, and at the end of the frac job we had about 4,000 gallons of liquid CO2 left over. Well, they didn't want to haul it all the way back to the factory, so we just dumped it. Well, this was 1985, and you did that kind of thing in 1985. And so we backed our truck up to the edge of this location, and the guy went to the back, opened the valve, and it was really a kind of a cool, humid day. And we watched this CO2 come out of the back of this as liquid, immediately flash to a vapor, a nice big condensation cloud around it, and flow down this hill. Sometime about a half hour later, we thought, wonder what happened down there. I went, walked down, there was a supervisor on the location, went to walk down there with the landowner, and we found it was a prairie dog town. How many of you guys ever seen a prairie dog town? There's a lot of them critters, right? And there was dead and dying prairie dogs everywhere. And the landowner remarked, hey, this is a pretty good way to get rid of prairie dogs. It flowed down the hill just like water. I was amazed. CO2 will flow down the hill until it disperses naturally. The time and distance for the dispersal, I'm going to read this, is going to depend on, number one, the lay of the land, steep hills, that sort of thing, the air temperature. The warmer it is, the quicker it'll disperse. Wind strength, wind direction, probably two of the biggest factors. The size of the rupture, the quantity of the rupture, the humidity, and even factors such as if there's a corn crop standing in the field and how tall that corn crop is. It's a very complex issue. In the event that you have really light winds, it's going to not disperse very quickly. It's going to tend to hang around. And in fact, if that light wind is blowing up the hill, it's really going to hang around even longer because it's going to resist that flow down the hill of that heavy gas. At the point of the release, the atmospheric concentrations could be 100%. 100%. It's going to decline with distance from that release based on all of those factors I told you about. A release from a CO2 pipeline will result in the entire emptying of that pipeline. And in just a few minutes, I'm going to talk to you about a place in Satartia, Mississippi, where that exactly happened. It's going to run, because it's a supercritical energized fluid, that pipeline is going to empty till the pressure inside that pipeline is at atmospheric pressure. We'll talk about some volumes. We need to talk about a thing called an HCA. well, excuse me, when this empties, it's going to empty the entire pipeline between shutoff valves. The pipeline has automated, not automated, but shutoff valves. So we need to talk about an HCA. What is an HCA? It's a high consequence area. A recent rule by the PHMSA, the Pipeline Hazardous Material Safety Agency, federal agency, effective October 5, 2022, says, I'll read it, valve spacing must not exceed 15 miles for segments that are in or could affect an HCA. Valve spacing must not exceed 20 miles for segments that could not affect an HCA. What's an HCA? That's where people live. That's the exact definition of an HCA is, as you can imagine, it's a bureaucratic definition. It's very complex. It depends on people, density, and distance. The closer the people, the bigger the concentration of people, the closer is an HCA. I can tell you, I lived in Lake County for a long time. There's only a few places in Lake County that would constitute an HCA. The pipeline runs across, the proposed pipeline runs across the southwest corner of the county, and I don't think there's an HCA there. So you're looking at, they got to put the valves at least no farther than 20 miles apart. Given the economics of the situation, well, I haven't seen a plan. I learned a long time ago you don't look at the last generation of plan, you look at the one that's being approved, because they do change. Sometimes they change significantly. For 20 miles in a 24-inch pipeline, which is the pipeline that I understand is being proposed, that's 2.7 million gallons of liquid CO2. That's a lot. When CO2 comes out into the atmosphere for the pipeline, it expands on a ratio of about 500 to 1. And the reason I say about is that depends on a lot of things like temperature and atmospheric pressure. So about 500 to 1. It turns into a lot of gaseous CO2. Talk about Satartia, Mississippi. And the reason I want to talk about this is I think it gives you an idea of a potentially real world situation. At 7:06 in the evening, the leak occurred. At 7:07, a low pressure alert was transmitted to their facility in Texas. This is in southern Mississippi, their facility in Texas. 7 minutes later, the valves closed, that's pretty good, 7 minutes. At 7:45, word was getting out in the county something's going on. At 7:45, the fire chief and the emergency management director hadn't heard anything from anybody, so they called the company and said, and I've listened to the phone call, and I won't paraphrase it, I won't tell you exactly what it was, but what in the heck is going on here? The company said, yeah, there's been a release, we'll get back to you. They never did. 9/11, the 9/11 operators were told that it was a natural gas leak. And that's the word they put out to first responders. They're going to respond to a natural gas leak a lot different than you respond to a CO2 release. And in fact, most of the first responders in the county didn't even know that there was a CO2 pipeline in their county. That's not going to be the case here, obviously, but that was the case there. By 11 o'clock, there was no product observed coming from the failure location. This thing leaked for 4 hours. An interview with a local fireman, first responder, when they asked him, well, how did you know where the release was? He said, we heard it. We could hear it from miles away. It sounded like a jet engine. This pipeline broke because there was a landslide. It was really poorly, from a geologic standpoint, really kind of poorly designed. But when the earth shifted and broke this pipeline, it self-excavated a crater about 40 feet across and froze everything solid. This stuff is really cold when it releases like that. Metallurgical analysis, and this is kind of important, showed both a brittle and a ductile failure. A ductile failure is where the metal stretches and then breaks. And that was the principal failure because of the earth movement. The brittle failure was because of the cold. It got so intensely cold that the steel got cold. When steel gets to a certain temperature, it becomes very brittle and breaks very easily. And so the pipeline completely separated, completely open. It was a 24-inch pipeline. It was 1 mile from this little town of Satartia. Interestingly enough, in the dispersion analysis that the pipeline company did, this little town was not in that area. And because of that, the town really didn't even know it was there. They were pumping it at 1,400 psi, and the valves were 9.55 miles apart, giving us about 138,000 gallons of liquid CO2 that was released in a 4-hour period. The Pipeline Hazardous Materials Safety Agency wrote a report that says, in the worst case scenario for this rupture, with a wind speed of 4.5 miles an hour and atmospheric stability, reading from the report, the CO2 cloud reaches 50,000 parts per million at 1,560 feet from the location of the rupture. 1,560 feet. Yeah, what about a quarter mile? 20,000 parts per million at 2,280 feet, about a half mile, and 5,000 ppm at 4,000 feet. The dispersion model that they had underestimated all of those numbers. And it goes on to say and conclude, for the releases modeled in this report, the maximum extents occur within 10 minutes of the initial release. So in 10 minutes, it had gone as far as it was going to go in 10 minutes. Think about what you can do in 10 minutes. Think about, I don't want to do this, but think about sleeping at home in 10 minutes. 10 minutes, just, 10 minutes ain't a whole lot of time to do anything. From a local emergency planning committee, first responders standpoint, 10 minutes is nothing. It's nothing. Let's talk about setback determinations. Oh, excuse me. One more thing about Satartia. There we go. "49 people were hospitalized. One person was according to the report, one person was unconscious for about 45 minutes, 0.6 of a mile from the release. 200 people were evacuated. Think about that at Madison Regional Hospital. What are you going to do? The modeling they did for Satartia was inadequate. It just wasn't good enough. So one of the biggest issues to me are the setback determinations. Where do we put this pipeline? Whose house do we put it next to? Where do we put it to avoid these kinds of issues? The Illinois Commerce Commission, this pipeline goes to Illinois. Illinois Commerce Commission took a really hard look at it, and they interviewed a lot of experts. And one of the foremost experts in the field, a guy named John Abraham, he's a PhD and he's written papers and he's an incredibly smart guy. There's 2 ways you model this stuff. One is called FAST, which is Process Hazard Analysis Software Tool. It's a commercially available software. It's a few $1,000 to buy it, but you can buy it. And computational fluid dynamics. FAST works with gaseous issues. Computational fluid dynamics deals with fluid issues. CO2 acts as a fluid, even though it's a gas, because of its density relative to atmosphere. It acts as a fluid as it's released. Mr. Abraham, and maybe I'll shortcut this a little bit. Mr. Abraham says the state of the art in the FAST modeling is grossly inadequate, shouldn't be relied on, and should not be used to establish setbacks from the pipeline. That computational fluid dynamics is the gold standard. I could run the FAST software on my home computer. I could not run computational fluid dynamics on my home computer. I ain't smart enough to do that anyway. That's very high state of the art. It's very expensive, and it takes a very long time to model the entire length of the pipeline. So that brings me to the question of, in South Dakota, how are we going to establish setbacks? What kind of analysis is going to be done, number one? Number two, who's going to review that work for accuracy and appropriateness? Do we have anybody in the state of South Dakota, especially in the government, that knows how to evaluate that? Or will the PUC look at it and go, hey, it looks good to me? How will that be evaluated? And that's one of the questions I have on the SB 201 when we get to that. Lake County, a little closer to home. Lake County is not likely to be identified as a high consequence area. And so the valves can be as far apart as 20 miles. Doesn't mean they have to be that far apart, but they can't be any farther apart. And remember, for 28 miles, that's about 2.7 million gallons of liquid CO2 in the event of a release. In contrast, the Satartia release was 1.3 million gallons, so about twice what they had released there. I'm not saying that this pipeline's going to leak. All pipelines end up leaking, pretty much. I'm not saying it's going to leak, but I'm saying the consequences of a release are serious enough that you have to assume that it's going to happen, and you have to be prepared. I've driven a couple million miles in my car in my lifetime and never needed a seatbelt, but I put the damn thing on every time I get in. You got to be ready for what could happen. There are some questions that I think y'all ought to be asking, and maybe you should be asking. I'll give this to you when I'm done. As a resident of Lake County, and I live about 1.5 miles from the Wentworth plant and about 1 mile from their pipeline, okay? So these are questions I think I need to know too. Will I be informed if I am in a potentially affected area but not a pipeline property owner? What notification will I get? It's on your property, but I live next to you. Will the dispersion analysis results be made public? The law says some of it can be kept confidential. One of my questions is confidential from whom? How much is confidential? And as a guy that's worked on a lot of pipelines, why? I would want to know that. How will I be notified of a release? There's a release. How does that word get out? They set off the sirens and I think it's a tornado. How does that happen? What will be the timing of that notification? In Satartia, a lot of the people never did get notified. And you can go online and search for that and read a ton of first-person experiences. You know, the fire truck drove into the plume and their fire truck quit because of oxygen starvation. And fortunately, the guys had their SCBAs on, and they wondered what the hell happened to our fire truck. From whom will I receive the notification of a release? Who's going to call me, and how are they going to do that? If there is a release, what information can I expect? Will they tell me where the release is at? And you guys all live out in the country. You know which way the wind's blowing every day, don't you? Pretty much all the time. So if I know the wind's blowing out of the northwest and the release is to my south, I might not worry as much about it. If it's to my northwest, I know I'm not going to run north. I'm going to run east or west. So will they tell me where this release is at? If there is a release and I'm impacted, how will I be compensated? The law says that they'll have liability. Having worked on a lot of pipeline releases and some of those very, very large price tags, what's the limit on that liability? Every insurance policy in the planet has a liability limit. The law doesn't specify what that limit should be. Somebody gets killed, what's that worth? How ready are my local authorities to respond to a release? I know the guys at the Wentworth Fire Department, taking some training with them. Terry's a good guy. I'm sorry, they're not equipped to respond to a release like this. They're just not. So where's that training going to come from, and where's that awareness going to come from, and where's that equipment going to come from? Where the pipeline crosses streams and rivers, what are the protections against erosion? That's one of the big ways pipelines leak. Now, if it leaks down in the creek, you know, it's tough on the fish. That actually might be a mitigating factor. What happens when the pipeline ceases operation? What happens? The pipe stays in the ground? The pipe doesn't stay in the ground? Who takes it out? Do they take it out? What happens? And lastly, I said I wasn't going to look at the legislation, but I have some questions about SB 201 that are of a technical nature, not a legislative nature. Below cultivation, 48 inches deep below cultivation. So if this goes across your property, are you now prohibited from putting drain tile in that easement? And if so, how do you do that? Depth below the river bottom. How is that determined? Having done some bathymetric surveys, you know, that's not an exact number. It just isn't. And that I've seen in any of the regulations, maybe I missed it, maybe somebody can point me in the right direction. I've not seen protections for stream crossings. Not seen it. Shall be liable. What's the limit of liability and what's the life worth? Is it open-ended? I have worked on projects where the pipeline company said, that's it, that's all the money we got, that's all the money we're going to spend, go pound sand. And as the guy that was hoping they'd pay me, I paid attention to that. An agricultural impact mitigation plan. Is there any landowner approval in that? Or they just tell you what they're going to do and you have to accept it? Or do you get to negotiate? What's it worth? Must offer dispersion analysis to the commission. Doesn't say the commission has to approve it. I'm sure that's part of the permitting process. But it doesn't say that. It says it has to be submitted. And that's my biggest issue is the dispersion plan that leads to setbacks. Who reviews it? What's their qualifications to review that? What's the negotiation that goes around that? And as a landowner, do you have a voice in that? Good question. And the last one, certain portions of the dispersion analysis can be declared confidential. As somebody that's worked with first responders, nothing can be confidential from those guys. They're the guys that are rushing into the fire, literally. They're the guys that are going in harm's way. And having worked with those guys, I'm not one of them, I'm too damn old. I think they got to know. I don't know that there's any part of this that's, I've never seen any petroleum pipeline dispersion analysis, and having done some of them, where any of it was confidential. It was part of the public record. It's in the public domain, and it's something people need to know. So that's what I got for you. Good questions later. Oh, if you have a question, speak up loud so I can hear you.
We're running a little bit late, so please speak up. Go ahead.
The question was, they can't give you a pinpoint plume prediction on what's going to happen at your house if there's a release. There's a guy in Great Britain, and he's well known for his work in dispersion analysis. And this is anecdotal information. I don't have a reference, but he said it'd take 44 years of computer time to do this pipeline, to perform that sort of detailed analysis, primarily because you have to incorporate changes in wind direction, changes in wind speed, humidity, and temperature. And you add all those variables, all that distance, all the differences, and it becomes very, very, very intensive. And it turns into garbage in, garbage out. What would you like it to be? Yes, ma'am. From a health and safety standpoint in Satartia, yes, there was H2S in the gas. H2S, from a technical standpoint, has a very low odor threshold. And reportedly, the H2S concentration exceeded that odor threshold and literally gave people a warning. Something's going on. I smell it. That's why they thought it was natural gas, because they smelled the H2S. It gave them a warning. Carbon dioxide has no odor threshold. It has no odor. Pop open your favorite carbonated beverage and take a whiff. All you're going to smell is the beverage. You're not going to smell the CO2. Your nose is going to tingle a little bit. And that's all the warning you're going to get. So at Satartia, yes, there was H2S in it, and it may have had an unintended beneficial consequence. Well, that's a pretty good question. Who determines what an HCA is, and do they? I think that has to come in the application, and I'm hoping that someone with knowledge of that would look at it and determine whether it was true or not.
Somewhere in the reading that I've done, I think it said that the operator determines high concentration.
Well, the operator does the work to determine it. Who reviews it, and what's the credentials of the people that review it is a question. Pipelines are built in straight lines. Remember that. I don't like to go around corners. Last one. In Satartia, it wasn't very long till the company filed for bankruptcy, and they were bought by Exxon. And I don't know the depth of those pockets. I haven't followed the legal part of that. It's outside my wheelhouse. And Craig, you tell me.
We got to keep moving here.
We got to keep going. Thank you.
Hopefully there's going to be a little time for all three to step up. Jim will step up. I have a screenshot of something I got off Successful Farming magazine. The headline is, Summit says it wants to withhold safety report to protect public safety. I'll let you guys figure that one out. Anybody can find this.